हेलो दोस्तों, बिगनर्स पॉइंट में आपका स्वागत है। और अभी हम कर रहे हैं इकोनॉमिक्स। ठीक है। शॉर्ट रन कॉस्ट, वी हैव प्रीवियसली डिस्कस्ड द शॉर्ट रन एंड द लॉन्ग रन। इन द शॉर्ट रन, some of the factors of production cannot be varied and therefore remain fixed. ठीक है। The cost that a firm incurs to employ these fixed inputs is called the total fixed cost, TFC, whatever amount of output the firm produce. This cost remains fixed for the firm. To produce any required level of output, the firm in the short run can adjust only variable inputs accordingly. The cost that a firm incurs to employ these variable inputs is called the total variable cost, TVC. Adding the fixed and the variable cost, we get the total cost TC of the firm. TC equals to TVC plus TFC. In order to increase the production of output, the firm must employ more of the variable inputs. As a result, total variable cost and total cost will increase. Therefore, as output increases, total variable cost and total cost increase. In table 3.3, we have an example of cost function of a typical firm. The first column shows different levels of output. For all levels of output, the total fixed cost is rupees 20. Total variable cost increases as output increases. With output 0, TWC is 0. For 1 unit of output, TWC is rupees 10. For 2 unit output of 2 units of output, TWC is rupees 18, and so on. In the fourth column, we obtain the total cost TC as the sum sum of the corresponding values in second column TFC and the third column TVC at zero level of output. TC is just a fixed cost and hence equal to rupees 20. For 1 unit of output, total cost is rupees 30. For 2 units of output, the TC is rupees 38, and so on. The short run average cost SAC incurred by the firm is defined as the total cost per unit of output. We calculate it as SAC equals to TC upon Q. In table 3.3, we get the SAC column by dividing the values of the fourth column by the corresponding values of the first column. At zero output, SAC is under undefined. For the first unit, SAC is rupees 30. For second units of output, SAC is rupees 19, and so on. Similarly, the average variable cost AVC is defined as the total variable cost per unit of output. We calculate it AVC, average fixed cost, AVC, average variable cost, equals to TVC upon Q. ठीक है। Also, average fixed cost is AFC equals to TFC upon Q. Clearly, SAC is equal to AVC plus AFC. In table 3.3, we get the AFC column by dividing the values of the second column by the corresponding values of the first column. Similarly, we get the AVC column by dividing the values of the third column by the corresponding values of the first column. At zero level of output, both AFC and AVC are undefined. For the first unit of output, AFC is rupees 20 and AVC is rupees 10. Adding that them, we get the SAC equal to rupees 30. The short-run marginal cost (SMC) is defined as the change in total cost per unit of change in output. SMC equals to change in total cost divided by change in output, delta TC upon delta Q is equal to SMC, where delta represents the change in value of the variable. The last column in table 3.3 gives a numerical example for the calculation of SMC. Values in this column are obtained by dividing the change in TC by the change in output at each level of output. Thus, at Q equals to 5, change in TC is equal to TC at Q5 minus TC at Q4. कितना हो जाएगा 4. Change in Q1, SMC is equal to 4 divided by 1. Various concepts of cost. आउटपुट यूनिट कितना हो जाएगा 0, TFC 20, TFVC 0, TC 20, TFC टी, ये सब पूरा वैल्यू ऐसे करके टेबल फॉर्म हो जाएगी, सबकी वैल्यूज निकाल लेंगे जब. Just like the case of marginal product, marginal cost also is undefined at zero level of output. It is important to note here that in the short run, fixed cost cannot be changed. When we change the level of output, whatever change occurs to total cost is entirely due to the change in total variable cost. So in the short run, marginal cost is the increase in TVC due to increase in production of one extra unit of output. For any level of output, the sum of marginal costs up to that level gives us the total variable cost at that level. One may wish to check this from the example represented through table 3.3. Average variable cost at some level of output is therefore the average of all marginal costs up to that level. In table 3.3, we see that when the output is 0, SMC is undefined. For the first unit of output, SMC is rupees 10. For the second unit, the SMC is rupees 8 and so on. ये दिखा रखा है फिगर 3.3 में कॉस्ट है. These are total fixed cost TFC, total variable cost TVC, and total cost TC curves for a firm. Total cost is the vertical sum of total fixed cost and total variable cost. Shapes of the short run cost curves. Now let us see what these short run cost curves look like. You could plot the data from in table 3.3 by placing output of the x-axis and cost on the y-axis. Previously, we have discussed that in order to increase the production of output, the firm needs to employ more of the variable inputs. This results in an increase in total variable cost and hence an increase in total cost. Therefore, as output increases, total variable cost and total cost increases. Total fixed cost, however, is independent of the amount of output produced and remains constant for all levels of production. Figure 3.3 illustrates the shapes of total fixed cost, total variable cost, and total cost curve for a typical firm. जैसा कि इसमें ये दिखा रखा है. We place output the x-axis and cost of the y-axis on the y-axis. TFC is a constant which takes the value C1 and does not change with the change in output. It is therefore a horizontal straight line cutting the cost axis at the point C1. At Q1, TVC is C2 and TC is C3. AFC is the ratio of TFC to Q. TFC is a constant, therefore has Q increases. AFC decreases. When output is very close to zero, AFC is arbitrarily large and as output moves towards infinity, AFC moves towards zero. AFC curve is, in fact, a rectangular hyperbola. If we multiply any equal Q of output with its corresponding AFC, we always get a constant, namely TFC. Figure 3.14 shows the shape of average fixed cost curve for a typical firm. We measure output along the horizontal axis and AFC along the vertical axis. At Q1 level of output, we get the corresponding average fixed cost at 5F at F. The TFC can be calculated as TFC is equal to AFC into quantity OF into OQ1, the area of the rectangle OFCQ. We can also calculate AFC from TFC curve. In figure 3.5, the horizontal straight line cutting the vertical axis at F is the TFC curve. At Q0 level of output, total fixed cost is equal to OF at Q0. The corresponding point on the TFC curve is A. Let the angle AOQ0 AOQ0 ये वाला एंगल is be theta. ठीक है. The AFC at Q0 is AFC TFC divided by quantity और क्या आ जाएगा आंसर tan theta. The total fixed cost curve, the slope of the angle AQO0 gives us the average fixed cost of किसकी कॉस्ट दे रहा है ये इसकी average fixed cost. Let us now look at the SMC curve. Marginal cost is the additional cost that a firm incurs to produce one extra unit of output according to the law of variable proportions. Initially, the marginal product of a factor increases as employment increases, and then after a certain point, it decreases. This means initially to produce every extra unit of output, the requirement of the factor becomes less and less, and then after a certain point, it becomes greater and greater. As a result, with the factor price given, initially the SMC falls, and then after a certain point, it rises. SMC curve is therefore U-shaped. At zero level of output, SMC is undefined. The TVC at a particular level of output is given by the area under the SMC curve up to that level. Now what does the AVC curve look like? For the first unit of output, it is easy to check that SMC and AVC are the same. So both SMC and AVC curves start from the same point. Then as output increases, SMC falls, AVC being the average of marginal cost also falls, but falls less than SMC. Then after a point, SMC starts rising. AVC, however, continues to fall as long as the value of SMC remains less than the prevailing value of AVC. Once the SMC has risen sufficiently, its value becomes greater than the value of AVC. The AVC then starts rising. The AVC curve is therefore U-shaped. As long as AVC is falling, SMC must be less than the AVC. As AVC rises, SMC must be greater than the AVC. So the SMC curve cuts the AVC curve from below at minimum point of AVC. In figure 3.7, we measure output along the horizontal axis and TVC along the vertical axis. At Q0 level of output, OV is the total variable cost. Let the angle is Q0 be equal to theta. Then at Q0 the AVC can be calculated as AVC TVC divided by output. आंसर क्या निकल के आ जाएगा 10 theta. The total variable cost curve. The slope of angle E0Q gives us the average variable cost at Q0. In figure 3.6, we measure output along the horizontal axis and AVC along the vertical axis. At Q0 level of output, AVC is equal to OV. The total variable cost at Q0 is TVC is equals to AVC into quantity, OV into OQ, the area of the rectangle OV BQ. Let us now look at SAC. SAC is the sum of AVC and AFC. Initially, both AVC and AFC decrease as output increases. Therefore, SAC initially falls after a certain level of output production. AVC starts rising, but AFC continues to fall. Initially, the fall in AFC is greater than the rise in AVC, and SAC is still falling. But after a certain level of production, rise in AVC becomes larger than the fall in AFC. From the point out onwards, SAC is rising. SAC curve is therefore U-shaped. It lies above the AVC curve, with the vertical difference being equal to the value of AFC. The minimum point of SAC curve lies to the right of minimum point of AVC. Similar to the case of AVC and SMC, as long as SAC is falling, SMC is less than the SAC. When SAC is rising, SMC is greater than the SAC. SMC curve cuts the SAC curve from below at the minimum point of SAC. Figure 3.8 shows the shapes of short-run marginal cost, average variable cost, and short-run average cost curves for a typical firm. AVC reaches its minimum at Q1 units of output. To the left of Q1, AVC is falling and SMC is less than AVC. To the right of Q1, AVC is rising and SMC is greater than AVC. SMC curve cuts the AVC curve at P, which is the minimum point of AVC curve. The minimum point of SAC curve is S, which corresponds to the output Q2. It is the intersection point between SMC and SAC curves. To the left of Q2, SAC is falling and SMC is less than SAC. To the right of Q2, SAC is rising and SMC is greater than SAC. Long run cost. In the long run, all inputs are variable. There are no fixed costs. The total cost and the total variable cost therefore coincide in the long run. Long run average cost LRAC is defined as cost per unit of output that is LRAC equals to TC divided by Q. Long run marginal cost LRMC is the change in the total cost per unit of change in output. When output changes in discrete units, then if we increase production from Q1 minus 1 to Q1 units of output, the marginal cost of producing Q1 unit will be measured as LRMC equals to TC at Q1 units minus TC at Q1 minus 1 units. Just like the short run, in the long run, the sum of all marginal costs up to some output level gives us the total cost at the at that level. Shapes of the long run cost curves. We have previously discussed the returns to scales. Now let us see their implications for the shape of LRAC. IRS implies that if we increase all the inputs by a certain proportion, output increases by more than that proportion. In other words, to increase output by a certain proportion, inputs need to be increased by less than that proportion. With the input price given, cost also increases by a lesser proportion. For example, suppose we want to double the output. To do that, inputs need to be increased, but less than double. The cost that the firm incurs to hire those inputs therefore also need to be increased by less than double. What is happening to the average cost here? It must be the case that as long as IRS operates, average cost falls as the firm increases output. DRS implies that if we want to increase the output by a certain proportion, input need to be increased by more than that proportion. As a result, cost also increases by more than that proportion. So, as long as DRS operates, the average cost must be rising as the firm increases output. CRS implies a proportional increase in input resulting in a proportional increase in output. So the average cost remains constant as long as CRS operates. It is argued that in a typical firm, IRS is observed at the initial level of production. This is then followed by the CRS and then by the DRS. Accordingly, the LRAC curve is U-shaped curve. Its downward sloping part corresponds to IRS and an upward rising part corresponds to DRS. At the minimum point of the LRAC curve, CRS is observed. Let us check how the LRMC curve look like. For the first unit of output, both LRMC and LRAC are the same. Then as output increases, LRAC initially falls and then after a certain point it rises. As long as average cost is falling, marginal cost must be less than the average cost. When the average cost is rising, marginal cost must be greater than the average cost. LRMC curve is therefore a U-shaped curve. It cuts the LRAC curve from below at the minimum point of the LRAC. Figure 3.9 shows the shapes of the long run marginal cost and the long run average cost curves for a typical firms. LRAC reach its minimum at Q1. To the left of Q1, LRAC is falling and LRMC is less than the LRAC curve. To the right of Q1, LRAC is rising and LRMC is higher than LRAC. और इसके बाद ये हो जाता है हमारा समरी. For different combinations of inputs, the production function shows the maximum quantity of output that can be produced. In the short run, some inputs cannot be varied. In the long run, all inputs can be varied. Total product is the relationship between a variable input and output when all other inputs are held constant. For any level of employment of an input, the sum of marginal products of every unit of that input up to that level gives the total product of that input at that employment level. Both the marginal product and the average product curves are inverse U-shaped. Both the marginal product curves cuts the average product curve from above at the maximum point of average product curve. In order to produce output, the firm chooses least cost input combination. Total cost is the sum of total variable cost and the total fixed cost. Average cost is the sum of average variable cost and average fixed cost. Average fixed cost curve is downward sloping. Short run marginal cost, average variable cost, and short run average cost curves are U shaped. SMC curve cuts the AVC curve from below at the minimum point of AVC. SMC curve cuts the SAC curve from below at the minimum point of SAC. In the short run, for any level of output, sum of marginal costs up to that level gives us the total variable cost. The area under the SMC curve up to any level of output gives us the total variable cost up to that level. Both LRAC and LRMC curves are U-shaped. LRMC curves cuts the LRAC curve from below at the minimum point of LRAC. ठीक है, और इसी के साथ ये चैप्टर हो जाता है समाप्त। तब मिलेंगे अगले चैप्टर में।